Hi everyone, welcome to FTInsights. I'm Mike Fibus. You know, wearables have been getting more valuable for health and wellness, but I think what a lot of us are really waiting for are two things: blood pressure and glucose. So how possible are those? How imminent are they? That's the subject for today. And today we're fortunate to have with us to talk about it, Dr. Stephen LeBoeuf. He's president and co-founder of Valencell. LeBoeuf, great to see you again. Thanks for joining us.
Nice to be on your show.
Yeah, so let's start with blood pressure. How I see, you know, the traditional cuff folks trying to make them smaller and smaller, you know, even down to the wrist, as Omron is trying to do. And I know the traditional wearable suppliers are headlong trying to offer it through PPG technology. So catch us up. Where are we?
So, you know, Valencell, we studied this a long time ago in our history, and I love the cuff technologies that are out there. I like how folks are focused, have big efforts on trying to make those cuff-based technologies better and more comfortable. Omron, for example, arguably has been spearheading this, and I applaud those efforts. The PPG-based efforts have been led mostly by us at Valencell, and the inspiration and desire for the PPG is that you don't need an inflatable cuff around you, so you can take more measurements throughout the day without discomforting anyone. And then also you can get information on a wave-to-wave basis about a person, which can be interesting for various different things. The weaknesses of the PPG is that, you know, whereas with a cuff, you measure the blood pressure somewhat directly because you apply a pressure to the person and then you see how they respond. So for example, you might apply a pressure to the person and then listen for the garrote call sounds, or you might apply a pressure to the person and see or measure asymmetrically how the blood flow is changing. And so it's a great way to assess blood pressure directly, or at least quasi-directly. In contrast, with PPG, you're literally measuring the light scatter from blood flow. And that is not a direct measurement of blood pressure. What you see is the result of the blood pressure, the impact of the blood pressure on the PPG waveform. And because of that, it's tricky to actually pull in the accurate information. And a lot of things can cause differences there between a blood pressure cuff reading and a PPG reading.
Right. Now, the early efforts I've seen have not been here on the wrist, but, you know, cuffs like the pulse ox finger cuffs or in the ear is, I mean, I assume, you know, given how hostile a place the wrist is to collect data, that those will be first. Yes?
Definitely so. And the reason is because it's actually mostly to do with physiological reasons. Generally speaking, the wrist is really, it's a nice, great form factor. A lot of people like wearing wrist products. I mean, I'm wearing one now, but the thing about it is that the wrist really is a bad place to measure biometrics. It's not ideal for a bunch of reasons. The one that most people talk about is the motion artifacts. You know, you move your wrist around a lot, and the motion artifacts are very extreme. Your wrist moves in so many different ways. Another thing about the wrist too that's not so good is perfusion. There's not as much blood flow to the wrist. You know, if you cut yourself on your ear, I mean, you feel like you're going to die, you're going to bleed to death trying to patch that up. If you cut yourself on the wrist, it heals up, it clots up right away. Perfusion is very, very low. Another thing that's less talked about is the density of these things called arterioles, which are these interconnectors between your arteries and your capillaries. Now, those arterioles, they blow up like a balloon when your blood flows, and they really help amplify that pressure wave into the blood flow waveform. So areas where you have a high density of arterioles, like the ear and then also the finger, are really, forehead's also pretty good too, are really good locations to pick up a good PPG waveform that has a lot of blood pressure information, not just blood flow information. And the wrist is just a bad place for PPG-based monitoring of blood pressure. So
yeah,
that you'll see, you know, our technology, for example, is being evaluated by companies mostly on the finger side and then also on the ear side, the earbuds that are already there, because on the wrist side, it's just you can't hit the ISO standard of accuracy, which is what you want for FDA approval on the wrist today with today's technology. It'll get there, but we're still a little ways off.
Okay. All right. So that brings up two questions in my mind. One is, you know, we can solve one of the problems at least at night. You know, I know you can measure heart rate variability much easier at night because we don't move around. So do you think there's maybe a night watch kind of product that could come on the wrist sooner rather than later?
So I'd say, Mike, a couple of things here. One is that, the biggest limitation of the wrist is not the motion artifacts as much as it is the lack of density of those arterioles.
Okay.
So that's a limiting factor. But that said, at Valencell, it's interesting. I don't know, have you ever been to our lab?
No.
So if you ever been to our lab, we've got people, they wear our sensors all over the place. So I don't know any other lab that actually does this because, most folks will either focus on the wrist or something like that, right? So they're wearing earbuds, they're wearing wristbands, they're wearing armbands, all at the same time while having these other benchmark devices on them. And so we get to see how the blood flow characteristics are at various different spots on the body, and then also get to see how well we can assess the blood pressure. And we have a blood pressure cuff in our lab that's an ambulatory blood pressure monitor that's been designed to measure blood pressure when people are exercising. It inflates an inflatable cuff. It's an FDA-approved inflatable cuff, so it's a good benchmark. And for some exercises, we find it's quite robust. So we put this on people, and we get to see how well we can track blood pressure. And what we find is that we have an output in our wrist products today. So literally, the folks who use our benchmark sensor system today on the wrist have this output already. It's an output that generates a pulse magnitude or a pulse volume indicator there. That pulse volume, we found, correlates directly with systolic blood pressure. Now, it does have to be calibrated to the person, but in principle, if a person took a few blood pressure measurements, they calibrated themselves, then they could track their blood pressure even while they sleep. So it does look promising for that particular use case.
Yeah, that's interesting. And the other thing I was wondering too is, that we don't necessarily have to replace the cuff with wearables. We can augment it. In other words, if we had sort of like a first responder check engine light, it seems like we could get accurate enough to do that much sooner than, actual FDA clearance accuracy.
Now, so and the short answer is yes. The longer answer is you do have to be careful, of course, because the wearables for screening are really interesting because the concept is the grand visage of this is that you have a wearable device that is got some basic acuity to be good enough to maybe put you into different categories of risk, and then if your risk is high, you might get special therapy or attention to see what really is wrong and what can really be done about you. Now, the thing to think about there is if you do that, the FDA has stated they will regulate that. So what's interesting is if you provide a general wellness information for someone and don't try to give them information about that they might be unhealthy or might need to see a doctor, that's okay. But as soon as you make suggestions that they might need to see a doctor, the FDA said they feel that at least they publicly said they feel that falls within the category of something they need to regulate. So you have to be careful about those two and then decide if you want to take the regulatory route or not.
Right. So what side of that equation is, hey, go get a cuff, pull out your cuff and check your blood pressure?
So, of course, only the FDA can flat out say that.
Okay.
From our understanding and the way we interpret it at Valencell is if you were to provide a solution that is a general wellness solution that is there to estimate your blood pressure for non-medical use and not used to treat any particular disease or not meant to give you a diagnosis of any type of disease, then that's something you can move forward with without FDA approval. But as soon as you make any medical claim, if you say that you are measuring blood pressure directly, or that you are providing a hypertension assessment, or you are helping someone triage themselves in a way you don't know whether or not they're getting a medical screening, anything like that, that's something that our understanding is that the FDA would want to see that approved by them before they would just let anyone run wild with that kind of thing.
Yeah, and now that I think about it, AliveCore's Cardioband, which is one of the best examples of this, where they have ECG, on the Bluetooth band, and then but their algorithm that sits in the watch monitoring PPG is also FDA approved.
Yeah, it's interesting because the cardiogram hardware itself, in showing an ECG on a wristwatch, the FDA does not need to approve that. that you could launch a wristwatch with an ECG on it, and you could say this is an electrical reading from your body and present it there, and that is not regulated. But if you do an assessment, one of the things about the guys at AliveCore is they have these novel assessments for atrial fib determination.
Right.
And other times, so I want to say not hypernatria, but I believe an excess amount of potassium in the body or something like this. They can, I believe, I think that's one of the things that they also do. Well, the FDA is saying, hey, if you're going to tell somebody this type of thing, then that's clearly making a diagnosis, and we don't feel comfortable with those products launching without our approval.
That makes sense. Okay. All right. So let's switch over to glucose. How possible is that? And it's clearly further off, if at all.
I was just talking about this earlier to some folks today, and I tell you, this comes across to me, Mike, sweet baby Jesus. You wouldn't believe how many times people come to me asking me for this. And let me tell you something. If this could be done, if Valencell has been studying this for a long time. I tell you, maybe we're not the smartest folks in the world, but we are pretty damn smart. And if we thought we really could do it, we could have raised the money a long time ago, tens of millions of dollars to work on this. I'm telling you, the people older and wiser than me, that they have a saying which has been shown to be true time and time again, is that never say never. That's a very juvenile thing to say, but I'm going to say never will there ever be. Now, let me phrase it this way. I'm telling you, I'm going to be right about this, not because I'm smarter than anybody else, but because of the laws of physics, which are, bigger than me. There will literally be stem cell regenerated beta cells in the pancreas to help people generate their own insulin before there's ever a truly non-invasive blood glucose monitoring technology that can be accurate enough to help you dose your insulin. So that's an important thing, because you can track glucose with PPG. That's been known for a long time. You know, one of the best ways to track glucose burst? I'm curious. Can you guess? You might know this just from savviness. Just in all the work you've done. You're never going to believe what's one of the best ways with existing technology on wearables to track a glucose burst.
No, I just assumed it's the finger prick. No, what is it?
For a wearable device, I should have clarified.
Okay.
For existing wearable devices today have something in them that is a great way to track a burst in glucose. Heart rate.
Oh, okay.
You have a motion sensor on you, and we know you're at rest. If we see a sudden jump in your heart rate, 9 times out of 10, roughly, that's going to be a glucose burst.
Really? No, I didn't know that.
And so what happens is these people think they're really on to something here, and they're really just tracking heart rate. And it's not helping you track it well enough or accurately enough to dose the insulin. See, the killer use case in glucose is not tracking glucose burst. People who are diabetics, they say, hey, I can kind of tell when I'm bursting up. The key in the real money-making business in helping diabetics with glucose monitoring is being able to help them track their glucose so they can dose insulin without being pricked, and then also continuous monitoring for continuous closed-loop insulin supply. Those two things, both of those require really, really, really accurate. You can't get that wrong. You can't make a mistake on that. Really accurate glucose dosing. And even today, Mike, the minimally invasive solutions like Dexcom's patch that they have, with the microneedles that are minimally invasive, so they pull in blood and interstitial tissue, fluids, and then do a glucose assessment. Those devices require a multi-day, many times a day calibration in order for them to work.
Right.
So, and those take blood from you, or fluids from you at least. And so the bottom line is that there's no physics that supports it. And I'll tell you, if you're interested, I'll give you 2 references for your audience here, that if you don't believe me, I strongly suggest you check John Smith's paper. If you search for John Smith, former director of Johnson & Johnson's glucose research arm, John Smith's got a paper out, I want to say it's called Chasing the Deceitful Turkey in Glucose Monitoring. He updates it again and again and again. It's beautiful. If you don't believe me, read his. If you want a much quicker read, there's a girl named Kate Bechtel, Dr. Kate Bechtel. She is with Triple Ring Technologies. She wrote an awesome article. Man, it's beautiful. In Physics Today about this. I want to say it's something about everything below the skin or something like that. But it's if you search for those two folks, you're going to get some good reads that explain this better than I even can.
Okay. All right. Let me ask you this then, back to that sort of the cardioband model. Do you think we could get close enough to, rather than aiming for being able to help make dosing decisions, but help make finger prick decisions, or, that I guess an engine light that comes on and says, you better check your glucose?
Yeah, I think that there is, so to make a short story long, definitely technologies are available today that have convinced me that you can give somebody an indication that their glucose may be going south. The problem is, so that's true. The problem is you can do that just by measuring heart rate alone. I mean, you don't need to do that. And so the thing about it is that the real money-making UK, this is how investors get screwed over. They get screwed over this way. People come to them and show them these preliminary results that, that saying that goes something like 95% of the work is the last 5% of the problem. So these scientists and engineers show them, hey, look, I've got these results that correlate, and we've only scratched the surface. Give us a few tens of millions of dollars, and we'll work this out. And the problem is that in glucose's case, it's not even the last 5%. It's the last 20% is difficult. That last 20% is so painful to get that just nobody has been able to do it because the physics isn't there. So
right.
Okay.
All right.
For spikes and stuff, technology's there, but it's just not marketable, and that's the limiting factor.
Yeah, no, you're right, and you're definitely right about being able to lure investors. I can't tell you how many clients ask me for to point them to the company that's solved this problem.
I've been fooled many a time by this, not just by other companies, but by myself. I thought we were tracking it, and then I realized that we just weren't going to get there. And then I educated myself more, and now I'm very thoroughly convinced that it is if people just put 10% of the research dollars they waste on truly non-invasive glucose monitoring onto something else, the medical world would be a much better place.
All right, fair enough. And I have seen some, pretty cool minimally invasive alternatives that's
really exciting and game changing.
Yeah.
People who are testing these out, I know some people personally who are testing these out, and it is remarkable. I mean, it has changed their lives. They do not have to be pricking all the time and this kind of stuff, especially type 1 diabetics. So this is really good. And the good news, it's not a science project. This stuff works, and it's only going to get engineering smaller, less invasive, less painful, easier to use in so many ways. And I'll tell you another thing I'm interested about is, some of these companies are doing studies with where they're taking PPG sensors like our technology, and they're having people wear these non-invasive glucose monitors. Okay, excuse me, minimally invasive glucose monitors, so they could track the glucose in real time. What they're trying to do is make a relationship between all the PPG readings and those readings to maybe be able to provide some premonition to develop new models that might be more useful, where you might not have to calibrate those patches so often. So it's based off the PPG readings. So it's only going to get better and better.
Yeah. Yeah. I mean, if we could get to every week or two, right? Yeah. If we get to every week or two instead of every 5 or 6 hours, that's a big difference. Yeah.
Absolutely.
Okay. All right. Hey, LeBoeuf, what can't you believe I didn't ask?
Well, I'm curious about this. I know that in the field, there's a lot of folks that are excited about the blood pressure technology we have coming out. There's a lot of folks who are lured by the glucose monitoring technology out there. But have you, in your research, seen anything else that you've been excited by besides those that can be integrated into these wearable devices that has you excited?
That's a good question. I've seen some promise with the blood pressure. I don't think it's quite there. That's one of the reasons I wanted to talk to you, but it's close, and that's exciting. I'll tell you one. I will point at a startup that I think has fascinating potential, and it's in the second area, the glucose. And have you heard of Profusa?
OMI, yeah. Profusa has the technology that is implantable. And
Yeah.
about it, it doesn't require a power source because it fluoresces and it's got chemical sensors in it that allow it to fluoresce externally, and you can pick up by the intensity of that light what's going on in the body. And I believe that the first use case they demonstrated is lactic acid in the body, and that buildup there, that to see whether or not you're going in the threshold or not, based on
Right.
this reversible chemical reaction that happens between that species and that enzymatic reaction on that sensor. And there's a direct linear correlation between the amount of the analyte and the fluorescence reading. So if they can scale this to a variety of other methodologies, like for example glucose, right? If
Yeah.
that can be done, then what's great about it is it's not truly non-invasive. It's very invasive, of course, but it's not doesn't need a battery, doesn't need all these other electronics. It can be inserted below the skin. So it's a really interesting company.
Right. And in fact, they're approved in Europe already to test oxygen levels. So they're putting it in, post-surgical for, to gauge healing. But my understanding is glucose is high on the to-do list. So maybe not much longer.
Yeah, I think that they'll probably be able to demonstrate glucose relatively quickly. The biggest challenge, that's one of the limitations with that technology, is that the chemical reactions that are required to make it work, some of them aren't as reversible as others. So depending on the species you're trying to measure, oxygen's a great one because the sensor's reversible. When the oxygen goes away, it goes back to its original state. It's not the same way with glucose. So you have to put a lot more technology in there to make it truly reversible. But those things are engineering challenges. They're not physics that doesn't exist, as in the case of non-invasive glucose.
Right. Right. My understanding is
In an engineering project.
right, exactly. My understanding is that light, eventually, renders them useless. And so, depending on where you put it, I mean, they guarantee at least a year, but if you put it where the sun don't shine, so to speak, you could get 5 years out of it. Anyway. That's a whole lot less minimally invasive, but let's leave that at that. All right. On that note, LeBoeuf, thank you so much for joining me. It was a pleasure as always.
Yeah. And we definitely look forward to keeping in touch and let you know about all the next generation technology that's going to be coming out of these PPG devices, beyond blood pressure and beyond, blood analyte monitoring. With the PPG technology, the really exciting thing is that you're going to be seeing is we have folks who use our technology to make new models to understand what's going on in the heart, all different types of heart conditions and all different types of cardiorespiratory conditions. And that's all real. It's based on real science. We've seen it. And so over the next 5 to 7 years, you're going to be seeing a lot of this roll out in these devices. And it will be game changing. It will be revolutionary.
Yeah, I'm excited. All right, great. Thanks again.
All right, Mike, you have a good one now. Thanks for letting me be on your show.
You too. And thanks to all of you. Until next time, bye-bye.